You're watching the Weiss Channel. Da, 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 da. All right, so today we're going to do an introduction to proofs. Write a proof for each pair of triangles, okay? So I'm going to prove that triangle REC is congruent to triangle DEC. So what we do is we always start with what's given. So you see, for example, these two slashes here and these two slashes here. That means RC is the exact same length as DC. So I say that RC is congruent to DC. That little equals sign with the squiggly above it means congruent. Congruent means same size and shape. So it's not just equal, it's exactly the same size and shape. Okay? That's given because it's given to you in the problem. Okay? See where the one slash is? Well, that means RC and DE are equal, or ER is congruent to ED. All right, so I have ED is congruent to ER. That's given. Now here you have EC, from E to C, is the same length for both triangles. So we say that it's equal to itself, right? It's equal to itself, right? That's called the reflexive property. When we say EC is congruent to EC, it's a little corny, but that's just the way it is, right? But hopefully it makes sense. That's called the reflexive property. So now what we have is three sides of one triangle are congruent to three sides of the other triangle. And so I can now say triangle REC is congruent to triangle DEC by side, 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 SSS. Okay? Here's my next one. I am going to start off with what's given. I'm going to say DE is congruent to GE. All right, that's given. Then I'm going to say that angle F is congruent to angle V. That's given. Okay. Now, when you have an X, here's your X, right? An X. This angle here is congruent to this angle here. That's always the case. These two angles are congruent also. That's called vertical angles. I remember vertical because they make V's at each other. Vertical angles. Vertical angles are equal. All right, so angle DEF is congruent to angle VEG. That's called vertical angles. Now I can say that the two triangles are congruent because I can say triangle DEF is congruent to triangle VEG because we have what's called angle, angle, side. Is congruent to angle, angle, side. Okay? Over here, I'm going to start with, all right, angle 1 here is congruent to angle 2. All right, but the way I have to write that is to either say FGH or HGF. That's angle 1. Angle 2 is either GHI or IHG. That's angle 2. So FGH is congruent to GHI, and that's given. I'm also going to say that GHF, or angle 4, is congruent to IGH, or angle 3. See how the two marks and the two marks, the double mark and double mark. Angle 1 and 2 have a single mark, right? Okay, so GHF congruent to IGH, that's also given, okay? And here we are with a side that's part of both triangles, right? So once again, this side is congruent to itself. So I'm going to say GH is congruent to GH. That's the reflexive property. Now I can say that the two triangles are congruent to each other. Triangle FGH is congruent to triangle IHG, and that's going to be, angle side angle. Okay. Over here, I'm going to say angle I is congruent to angle M. Notice, by the way, I can call it angle I and angle M because angle I is way out here all by itself. Compared to, say, these angles here, all right, I could call angle F, but this angle 4, I can't call it angle H because angle H is a combination of angle 2 and 4, right? So angle 4 has to be called FHG or GHF for that reason, all right? So I can call angle I, which is congruent to angle M, and that's going to be my first given. And then I'm going to say IJ is congruent to MJ. That's given. Now, I'm going to say that these two guys here are congruent because they're vertical angles, right? So I'm going to say, now of course I can't call that angle J, so I have to say IJK is congruent to MJL, all right? You could say KJI is congruent to LJM, either way, but it's vertical angles. Then I can say that the two triangles are congruent by angle side angle, okay? Over here, I'm going to say that this angle here is congruent to this angle here. WTS congruent to RST, that's given. And I'm going to say SR is congruent to TW, that's given. All right, once again, I have this guy congruent to itself. That's the reflexive property. ST is congruent to ST, or TS congruent to TS, either way. And then I'm going to say that the two triangles are congruent to each other. I have side, angle, side. Okay. SAS. All right. And over here, I'm going to say that AX is congruent to DX. That's given. And then I'm going to say BX is congruent to CX. That's given. And I'm going to say CXD is congruent to BXA. That's vertical angles. And then I'm going to say the two triangles are congruent by side, angle, side. Okay? You've been watching the Weiss channel.